Now, good morning, everyone. Grace, can you please turn it off? Thank you. All right, now we're going to get started. Now, can I please ask you to put this as the title? So today we're going to talk about trigonometric ratios. Okay. Now, so in the last lesson, we briefly, so this is a recap. And in the last lesson, we briefly talked about, or not briefly, we actually talked about it in details. Now, so we had a right angle triangle. Still remember that? And we also talked about the three sides, okay, and a reference angle, okay. Now that's what we talked about in the last lesson, didn't we? All right. So the reference angle has a symbol, and what symbol is that? It's theta. All right, theta. Cool. Now, so we also talked about the three sides, okay. Now, what's this side called? H. Very good. It's the hypotenuse. Excellent. Right? And since the reference angle is right there, where's the what about that side? What is it called? O. Very good. O. So that's your opposite. Oh my God, that's very dodgy O. All right. And where's A? A is adjacent. So adjacent means the side which is sitting next to the reference angle. Very good. Okay, so with that understanding over there, you should be able to understand trigonometric ratios pretty easily.
I love how there's triple double D's.
What double D?
What? Dylan Bennett, D stands for and D on the double D.
Sounds good. You better name our kids D's then. Now, so oh no, not our kids, sorry. Now, so I'm gonna draw three. Now, please start drawing. So three right angle triangles, all right? Biggest, medium, cutest. All right, now, okay? What's wrong? Oh, thanks. Different sizes, yes. Now, and let's not forget to put a right angle right there. Right angle right there. Well, that rhymes. Okay, so as you can see, all right, now all the reference angles are exactly the same. Okay, all the reference angles are exactly the same. Let's say, for example, the reference angle is 27 degrees. Okay, 27 degrees. Now, is that too small?
Yes.
I intend to write bigger. Make it bigger. So theta is 27 degrees, meaning to say the reference angle, they are all 27. Okay, 27 degrees, 27 degrees. Cool?
Yeah.
Okay, so that means the reference angle, their angles are the same, except the sizes are different. Now, we've already learned Pythagorean triples, so if that's 3, that's 4, then that's 5. Okay? If that's 6, that is 8, then that is 10. Okay? If that is 9 and that is 12, then that is 15. Okay? That's not primitive. Let's put it that way. Okay? They are the multiples. Now, so what trigonometric ratios really are is, now if you have a look here, the ratio, now do you know what ratio is? Okay, so if I say the ratio of 1 to 2, it also means what? 1 over 2. 1 divided by 2. They mean exactly the same. All right, now, so opposite, so the ratio, so this is a trigo ratio, so opposite over adjacent, okay?
Yes.
If you have opposite over adjacent, now let's figure that out. If you have a calculator, grab one, okay? Take it out. Now, I'd like you to press the calculator. Now, so the ratio for the first triangle here, opposite over adjacent, right? Now, how much is the opposite? 9, very good.
Yeah.
So 9 over, what is exactly? Adjacent is 12. All right, let's not press the calculator yet. Now, let's have a look at this one. What about this one? 6 over 8. And what about that one? 3 over 4. Now, press your calculators. 9 divided by 12, how much is that? 6 divided by 8, how much is that? And 3 divided by 4,
The decimal?
How much is it? Doesn't matter. Okay, 0.75. Now, what's 0.75 in fractions?
But those are working calculations.
3 over 4, 3/4. They're all the same. Alyssa said they're all the same. 0.75. There we go. Okay? They're all the same. Exactly. So the ratio is all the same, isn't it?
Yes.
Now, that's because they all have the same reference angle. So it doesn't matter how big the triangle is, as long as the reference angle is the same, the ratio of opposite to adjacent is always the same.
Yes.
Now, so all these are just the theories working behind the scene. Now, here comes the real deal. You have 3 trigo ratios. Now, trigonometric is too long for me, so I'll just summarize it into trigo. Okay, so 3 trigo ratios. Okay, I believe that you must have, at some point, heard about these before. Sine, cosine, and tangent. Now, these are the full names of sine. Yes, write it down. Sine, cosine, and tangent. They are the full names. Okay? But look, when we do math, we don't call them by their full names because we are too lazy. Yeah?
Yes.
Okay? So what we call them instead is sine, cos, tangent. Oh my God, again. Now, sine, cos, and tangent. Okay?
Oh, that's on the calculator.
That's on the calculator. Very good. That's a sharp observation right there.
Mom.
Yeah. So sine, cos, tangent, the 3 trigo ratios that we are going to use and manipulate. Okay? Now, so sine, cos, and tangent, the 3 trigo ratios. Now, first and foremost, you got sine. Now, sine theta. Theta is your reference angle, isn't it? So when you sine theta equals to, now, opposite, I'll write it in full for now, over hypotenuse. Or what I would much prefer to summarize it into O over H. Easier that way. Yeah?
I just did that anyway.
Yeah, cool, excellent. I like that. Cos theta equals to adjacent over hypotenuse. Okay, over hypotenuse. So that's a A over H. Righty? Now, last but not least, I've got tangent. Tangent theta equals to
A over
over A. Very good, John Ross. So opposite over adjacent,
Yes.
which is O over A. Those are the 3 trigonometric ratios that you must understand and perhaps remember it. So it's a bit like a times table. It's going to be really handy. It's like a times table in trigo. It's very handy when you remember them. Now, so what these ratios are doing, as you can see here, how many sides have you got? So these ratios, sine, cos, tangent, what are they trying to do here? They're trying to develop a relationship between what? Between an angle, the reference angle, which is theta, and to develop the relationship between the theta and how many sides? How many sides? 2 sides. Exactly. So what these ratios are trying to do is to connect or to develop the relationship between one theta, one reference angle, with who? With 2 sides. One side and another side. Okay? So with 2 sides. Hey?
Well, I don't know if I heard you right, but you said it has to make a relationship with 2 sides.
Yeah. We put it equal there.
That's called cheating, Mr.
Oh my God.
Yes.
Wow, John Ross. Wow. Okay. Well, he has got a point though.
He is a slut.
Oh wow. Okay. All right. Now, so let's solve a couple. Let's solve a couple of examples here. Now, if you can take out a booklet, take out booklet 2, take out booklet 2 and turn to 7.2 trigonometric ratios. Okay, page 402. So let's have a look here. Now, all done with this? All done with that? All done with that?
Yeah.
Yep. What about you guys? Dylan, Denise, Megan, Dion?
I forgot about that. I love you.
Oh, yeah,
Dion.
they can't talk. Sure. Yeah.
Yeah.
You guys done, right? Cool.
Why are they muting themselves?
Oh, because to avoid disruption.
Wait, this is what page?
Hey?
Okay.
Page 402. So let's take out booklet 2,
Yes.
page 402. I like Gracie's enthusiasm there. Yes, yes, yes. Okay, now, so let's get started. Question 1, I'm going to show you an example here. Question 1A. Okay, question 1A. Find the exact value, exact value of tan theta. So tan theta in each triangle. Now the first triangle, now part of my drawings, as beautiful as always. Now, you laugh at me.
Yeah.
Wow. Okay, so right angle right there, and your reference angle, your theta, is right there. All right, so that's your theta. All right, now, and it says that that's 7 centimeters, and that is 25 centimeters. Cool, and that is 24 centimeters.
Nice.
So now they want you to find the tangent theta. Now, tangent theta, so right, tangent theta equals to, now, what's tan? What's tangent theta? Very good. Opposite over
What did
adjacent.
Jesus say?
So opposite over adjacent, isn't it? So
Yeah.
now tell me, where is opposite? 7. Very good. Opposite's right there, isn't it? So opposite is 7 over what's adjacent? 24. Now 24.
3. I mean, no.
Okay? Alright. Now, ladies and gentlemen, that is tangent theta equals to 7 over 24. Done. Done. That's what they want. Okay? Now, yes. I like how you raised it, honey. Fraction form. Remember, I've told you before, when they're asking for, when they're demanding for exactly, the word exact. You can either leave it in what form, Gracie? Fraction, or what's the other one? Oh no. What? Yeah, square roots. Exactly, square roots. Okay? So, is this an exact answer?
Yeah.
Oh yeah. Okay? Because it's in fraction. Cool. Right now, let's do another example here. Okay? Now, so let's do another example. Oh my god. Now, so this is question 1, still question 1, B. Okay, so B, they ask you to find the exact value of sine theta, yeah? So sine theta, I'm gonna choose B2. All right, now. So right angle's right there, your theta is right there. That's 60 kilometers, that's 36 kilometers, that's 48 kilometers, okay? Now, so they're looking for sine theta. So sine theta equals to, sine theta equals to opposite over hypotenuse, really good, okay? All right, now, so what is opposite? Listen. What's opposite? Where is it? Where's the reference angle? Very good. 36. Exactly. 36 over hypotenuse. What's hypotenuse?
60.
Where's hypotenuse? 60. Very good. 60. Now, is that our final answer? It's not.
Simplify it.
We need to simplify it. Very good, people. So, what do they have in common? Six.
Number.
Yeah, a number which is 6. Cool. You guys are collaborating really well. So 36 divided by 6 is 6. So you cross it out and replace it with 6 over 10. Ooh, is that the simplest? No.
No.
Yep. So divided by 2, which gives you 3. Divided by 2, which gives you 5. Are we all following?
Yeah.
Yep. 3 over 5. Like, yes, go. Yes, exactly. Because they have 12 in time. Correct. Okay? Yeah. Very good. So sine theta is 3 over 5. Alright? It's a ratio, isn't it? 3 over 5. Cool. Now, I do not believe I need to give you any more examples because it seems like, yeah. 1A, right there. Oh, 1A3. Oh, 1A3. Yes, what's up with that? Ow! Okay. Alright then. I'll solve it with you. Alright, so question now. Corner request. Question 1A again, but 3. Roman 3. Roman 3. Now, so, right angle triangle right there. Draw a right angle triangle. Okay? Reference angle, theta. Alright? Now, the hypotenuse is 2.9 meters. That's 2.1 meters, and that's 2 meters. And you're looking for tangent. Tangent theta equals to opposite. Ooh, opposite over A, adjacent. Very good. Now, so where's opposite? Yeah. Oh, my bad. Yep. Someone.
Big dog.
What? Rocks. No big dog. Now, yeah. 2.1. So 2.1 over what's A? 2. What's A? 2. Very good. Alright. Exact value. Ooh. What's exact value there? Wow. Yeah, limit the fractions. Well, that's a fraction, isn't it? Well, 2.1 divided by what? 2. Okay. Now, what's it in fractions? What's it in fractions?
Oh,
yeah. Press a calculator. Okay. Now, actually, you don't really need to, right? You could just do multiply by 10 and then multiply by 10. Okay. Yeah, 21 over 20. That will eliminate the decimal, isn't it? But if you're not confident with that, all you can do is you can press your calculator right here. All right, I'll press it with everyone. So what you do is you go 2.1. Can we see that? Is it clear over your side? 2.1. All right, divided by 2 and press equal. Okay, so now, so
no, it's 1.05.
now, so 2.1 divided by 2, and then you want to convert it to fractions, right? So you tap on the fraction button there, and it becomes a fraction. All right. So
I have a fraction button.
Fraction button. Okay, the fraction button. That on there, and then it turns into a fraction, which gives you 1 and 1 over 20. Now that's a mixed number, isn't it? We are going to turn it into improper fraction. All you need to do is you hold shift and then you tap on the fraction button again, and it tells you 21 over 20. Now, of course, depending on what calculator you're using, it can be different. But for me, I've always loved, I'm not doing an advertisement here, but I've always loved to use Casio. Casio is my favorite. It's most math teachers' favorite as well, or students. What Casio is that? It's a very old model, 991MS. It's a very old model. Well, it has been with me for the past, how many years? 18. No, I'm not that old. Not 18. Like nearly, 10 to 20, yeah, 10 years. Yep. Okay, So now let's move on, continue. I'm going to show you an example for question 2. All right, now. Question 2. Question 2A. Find the value of the variable correct to 2 decimal places. So 2 decimal places. Now it's a very good rule of thumb. It's a very good rule of thumb to spend only 1 second to write out what the question really wants. Okay, so that you won't make careless mistakes. So 2 decimal places in the following triangles where sine alpha. Ooh, my God, sine alpha. What's that? Now, don't freak out. It's the same thing. Okay, it just means the reference angle. All right, but they use another symbol. Instead of theta, they use alpha. They could use beta if they wish. It just means A, B. Theta is T in Greek.
Ooh,
Yeah? Yeah.
You know alpha and beta?
Yeah.
That's why it's called alphabet.
Very good.
I just heard someone say
So it's alpha, beta. It's not beta, but Americans call it beta. Yes. Oh, Grace.
We're on recording.
I need to cut it out then. Jeez. Okay, now, so sine alpha, now that's what we're looking for. So, where sine alpha equals to 1/3. So they give you the ratio. They have given you the trigonometric ratios right here. So they tell you that sine alpha equals to 1/3. Now let's have a look at the first triangle right there. That one there. Okay. So if your alpha, your reference angle is right there, that's 20 kilometers. That is x kilometers. Okay. Now, what is x? They want you to find x. So before that, sine alpha equals to, now sine is what over what? O over h. Very good. So they tell you that the ratio of opposite to hypotenuse is 1:3, or 1/3. So, do you have opposite? No, that's what you're looking for, isn't it? That's what you're looking for. True? Now, have you got hypotenuse? Oh yeah, 20.
But what's the right angle?
So when you said, oh yeah, you reminded me of an Asian.
Now, so 3 is how much? 20. Okay? Now, so ladies and gentlemen, let's do this. I'm going to show you how to do this. Proportionality. If 3 is equivalent, now 3 lines, not 2. 2 means equal, 3 means equivalent. It's a symbol. Yeah, that's right. Yes. Okay, so
The middle one should be short.
yeah, the middle one should be short. Okay, now, so 3 is equivalent. So just in case you don't know what that symbol means, it means equivalent. Okay, equivalent. Now, so 3 is equivalent to 20 kilometers, isn't it?
Yeah.
Okay, now, what about 1?
X.
Now, what about 1? So 1 is equivalent to how much?
X.
Okay, yep, x. That's what we're looking for, isn't it? Okay, now how are you going to turn 3 to 1? Multiply or divide? Divided by, very good, divided by what? 3, very good, divided by itself. So 3 divided by 3 gives you 1. So if you divide it by 3 on the left hand side, what should you do on the right? Do the same, divided by 3. Now, grab your calculator, use your calculator. 20 divided by 3 is 6.66666666667. Now, we're going to round it to how many decimal places? 2 decimal places. So what would be the final answer? 6.667. Right, so you're confused. Go on, ask. Oh, that's all right. No question is a silly question. Come on, go on. Fire me. I mean, fire away. Oh,
You fire. You got
go
me thinking
on.
about
Have you got a question? Otherwise, I can attend to you later. Oh, confused. Okay. I'll chat with you later. Okay. All right. Now, I'm giving an example here. So let's do A, do B. All right. So do B.
Can you do C?
Okay. Yeah, I do B and C. So question 2B. Now tangent alpha. All right. Same thing. 2 decimal places. All right, so tangent alpha equals to, now I'm doing 2b1. Tangent alpha equals to 1 over 2. Okay, so tangent is what over what? Tangent alpha equals to what over what? Opposite of adjacent. Now, if you have a look at the triangle right there, okay, that's the right angle. That's your reference angle. All right, now, and that's X, and that's 26 centimeters. Okay, so they tell you that tangent alpha equals to 1 over 2. Okay, they've given you the ratio. All right, now, so that's opposite, isn't it? That's what we're looking for, X. True? Now, what about, now, what's that? Adjacent, isn't it? So adjacent is how much? That's 26, isn't it? Okay, so now, if that's 26 and that's X, true? Yep, now we can use proportionality. 2 is equivalent to how much? 26. 2 is equivalent to 26. Now, I'm looking for 1. So 1 would be how much?
1.
How are you going to turn?
Wait.
Yep. Your answer will be X, but how much is X?
13.
Does it make sense? Okay, so divided by how much? 2, isn't it? Because 2 divided by 2, you get 1.
Yeah.
If divided by 2 on the left, you got to do the same on the right. 26 divided by 2 is 13. So, Gracie, X is 13. Very good. X is 13 centimeters. Okay?
Also, that all we have to do is find the opposite.
Well, it depends on the question. Okay? Now, somebody requested, I don't know who was that, was it Dylan? Somebody requested me to do C. Okay, I'll do C then. So C1. So this time, C is cos. Cos alpha equals to 1 is 4 over 5. So what's cos?
A over H.
A over H, very good, A over H. So adjacent of a hypotenuse. Now, so we've got a triangle here, all right? Oh my God. All right, now, so alpha, oh, good God. Got the wrong diagram. Sorry. Okay. Now, so that's right angle right there. Reference angles right there. 60 centimeters and n centimeters. Now, cos alpha equals to adjacent of the hypotenuse. So I'm going to rewrite that here so that's clearer for you. Now, that's adjacent. Tell me, where is adjacent? Which one is adjacent? N. Very good. Very good. So n is adjacent.
Yeah.
So that is n. Okay. Now 5. What about hypotenuse? What about hypotenuse? 60. Very good. 60. So if 5 is equivalent to 60, what about 4? That's n. That's what we're looking for.
5, that's 1.
Yes, very good. Very good. Grace said we are going to turn it to 1 first. Because when we get to 1, we can get back to 4, isn't it? Very good.
Oh, right.
Yes, you were right. Absolutely right. Now, 5 divided by 5 gives you
Wow.
1. You divided by 5 on the left, you got to do the same on the On the right, so divide it by 5. 60 divided by 5. 12. Very quick. Good. Now, am I looking for 1 or am I looking for 4? 4. So I'm going to turn 1 to 4. And how am I going to do that? Times. Times it by 4. Now, if you times it by 4 on the left, you times it by 4 on the right. So 12 times 4 is 48. So n is 48.
48.
Okay? Alright? Now, those are the examples that I have given you, and I do believe that they will be enough. Alright, now, just to do a quick recap here. So, all you need to know for today's lesson is this. Your 3 trigger ratios: sine, cos, and tangent. Remember them. So, sine is opposite over hypotenuse. Cos is adjacent over h. Tangent is
Opposite of
adjacent. Now, all this time people have been memorizing it with different techniques. Some go so, you know, people use different techniques to memorize it. Hey? Yeah, and if you've got a mother tongue, you know, sometimes people use different languages to remember them. Okay? Some are hilarious. One's more hilarious than the other. It's completely up to you. Yeah? What? Uyu is Korean for milk.
Hey, I want your food.
But it's like my favorite word.
Milk.
Yeah, my favorite
Cool.
word is
Alright. Now, however, I've come up with a 21st century way of memorizing it. Okay? Now, let's share it. I'm going to share it with you. You can sing along if you like.
Let's go.
You can sing along if you like. Okay, I'm just going to turn the camera over there. Yeah? Right, let's test. There we go. No, he's not a bad guy.
Look at my side, look in your side, whoop. And please look at me, oh I'm triggering with whoop. Swinging side to side, am I cooling that whoop? I'm right angles are fine, and H opposite to you. Sounds like wanna dance, but I don't know how to First step, ooh, looking like a whoop. Her name's Tanny, ooh, she that more hyper whoop. I'm chilling where I hit the floor, I hit the whoop.
Yeah, it's too early in the morning. I could have done it better.
Is this still recording?
Hey?
You recording?
I think so.
Please stop someone else recording that. Oh, it's not honest.
Yeah.
I
Right,
remember one
so-
time we did like a floss dance. I'm pretty sure Zach and Thomas recorded that one.
Yeah, I could have done it better. It's too early in the morning. Yeah, Friday? Yeah, cool. Alright, ladies and gentlemen, that's all for our theory today. Now, you're just going to work on a question. Alright, so this is what you need to do.
Yeah, Zach already showed you that.
So, booklet 2, question 1 to 5. That's all. Not too many questions. And I believe that if you have completed that, then that's fantastic. This booklet 2, question 1 to 5. Oh, hang on a second. I should have given you the page number. It's page 400. So page 402, 403, 7.2. That's all we need to do. Yep.